So today we are talking about the electromagnetic spectrum. Now, this is an entire range of electromagnetic radiation. Notice that visible light is here. It is part of that range. It is a very small part of that range. They made it look bigger here just because this is the only part we can actually see. So we tend to focus on things we can see, right? Okay, so this is a wave of energy that exhibits wave like behavior as it travels through space, which is why we're seeing it as a wave here. All stars emit electromagnetic radiation. This is how we study the stars in a large extent. It's characterized by wavelength and frequency. The next slide tells us what the wavelength is. The wavelength is determined by the distance between one point of the wave and the next. Usually we go from crest to crest, but you could also go from trough to trough. It would be the same distance. The frequency is how fast are they moving. So how fast do they go through a given point, let's say point 0 here, in a given amount of time. So each one of these have many different uh, electromagnetic waves come in many wavelengths and frequencies, and each one we have found useful in different ways. So we're going to talk about how we use them. But remember that like the sun is emitting all of these at any given time. Again, the range goes from radio waves being the lowest frequency and the longest waves, all the way up to gamma waves, which have the highest frequency and the shortest waves. Radio waves. They have the longest wavelength, the lowest frequency, and the lowest energy. And this is why we use radio waves to broadcast sound, because it is a low energy, it's cheap and efficient. It travels easily through the atmosphere and other materials. Pictures blocking that right now. Radio waves are broadcast, which means created, by a transmitter, and this is what your transmitters look like. This is a radio station, and picked up by a receiver. So, like right now, we are being bombarded by radio waves, but we can't hear those radio waves unless we are using something that's going to pick it up and convert it back to sound waves that we can actually hear. So radio stations either change amplitude or the frequency. And so amplitude is when you go to the AM channel, and frequency is the FM channel. Here's something interesting. Televisions also use radio waves. They use the AM signal for the picture and the FM signal for the sound. Microwaves have shorter wavelengths, higher frequencies, and higher energy than radio waves, but just a little bit, right? Uh, Besides the obvious, microwaves actually are used in radar and cell phones. So that was how microwaves were actually invented. The story goes that a World War II person was sending stuff, had a chocolate bar on his radar thing, and he realized that it melted, and so he realized, hey, we can use microwaves. We could do different things besides just use for radio. Infrared. They have shorter wavelengths, higher frequencies, and higher energy than the microwaves. You can't see infrared light, but we can see it. Or we can feel it. Sorry, we can see it when we do something like this. This is an infrared camera. We can feel the results, like your toaster turns red hot, but before it turns red hot, you can actually feel heat coming off of it. If we could see in the infrared, we would see that the little strands that heat up in your toaster heat up very quickly. And then, like, these heating things also heat in the infrared, which are really nice when it gets cool out like it's been. Visible light, smallest part of the EM spectrum that humans can see. Smallest part of the spectrum, the only part that humans can see. The longest wavelength is red, the shortest wavelength is violet, and this is the visible light from the sun is white. So it's actually all wavelengths combined, and we see a rainbow when we get that light fractionated because of the moisture in the air and the sun hitting that moisture just right. The visible range of colors is called the visible spectrum. And there's this Roy G. Biv to help you remember. It goes red, orange, yellow, green, blue, indigo, which is like a deep blue, and then violet. There we go. And here's the actual wavelengths for each one of those. This will be the end of part 1, and we will continue with part 2.